In this example, we are going to do similar to a trace we just did for bags, only this time using lists. So here's our list interface. Again, we use generic so that the person who creates an object using our list interface will specify the data type that should go in the list. And the important thing to note about the list class that we're using is that in the description we see that entries in our list have positions that begin with 1. So our list begins with 1. Now this was a design decision that was made when the list interface was created. If you were writing your own list interface, you might choose to start at position 0. But you are not currently writing your own list interface. You're using this version of list interface, and so you have to follow the specifications defined in the interface, namely that that list begins at position 1. Now remember again that we're using just the interface, which means we don't know anything about how this is implemented behind the scenes. We don't know if it uses an array, we don't know if it uses linked nodes, we have no idea, and we shouldn't care about that. All we care about is using the methods provided in the interface and following those specifications that are in the interface, namely that positions begin with 1. Okay, so when we look at our methods here, we have 2 different add methods. So we have a way to add just a new entry, and here it says that that new entry will be added to the end of the list. Again, that's a design decision. You can make an argument that that entry should be added somewhere else, but the author of this interface chose to add new entries at the end. Entries that are in the list, currently in the list, will be unaffected, and the list size will increase by 1. So this description of the method tells you exactly what's going to happen when you add an element in this way. So this method takes 1 parameter. Then we have a second add method that takes 2 parameters. This method takes in the element you're adding as well as the position of that element. And we can read the description to say that the entry is added at that position. Entries at and above that position are at the next higher position within the list. So basically we're shifting everything down. So if we want to add something at position 2, for example, that new element would go into position 2, and what was previously at position 2 would get shifted to 3, 3 would get shifted to 4, 4 would get shifted to 5, and so on. Okay, so we have our description of the parameter, the new entry, and we also see that this method might throw an index out of bounds exception if the new position that we're trying to add is less than 1, since our list starts at 1, or greater than length plus 1, get length plus 1. We have one way to remove things from a list, and that's by specifying the position. So here we remove the entry at the given position, and then we can see that what happens is that our entries that were originally at that position, or higher than that position I should say, will all be shifted down by 1, and the list size will be decreased by 1. This can also throw an index out of bounds exception. We have a clear method to take everything off the list. We have a replace method that allows us to swap out an existing entry with a new entry at a specified position. And we get an element back returned to us. What gets returned is the entry that was replaced. So not the new entry, but the one that's being removed from the list and replaced. We have a get entry method that allows us to just access elements at the list. Again, this can throw an index out of bounds exception. We have a toArray method that allows us to access an array version of our list. A contains method, which allows us to test whether an element is on the list, giving us a true or false. A getLength, which tells us how many elements are in the list. And an isEmpty, which tells us whether there's anything in the list or not. So this is our interface. And we're going to walk through a similar example. So here is some code that uses these interface methods. We again have an animal list, and we're going to add some strings representing animals to our list. So here you can see that our list is ordered. So that is the main difference between a bag and a list. A bag is an unordered collection of elements. A list is ordered. So there is an order associated with list items. That was not the case for the bag. Again, remember that for our list class that we're using, our list starts at 1. Okay, so if we first were to print out is the animal list empty, we'd print out true, so there's nothing on the list yet. Then we add alligator, so alligator will get added to position 1. Bear will get added to position 2. Cat will get added to position 3. So we're down to here now. Dog will get added to position 4. Lemur will get added to position 5. Okay, so now we're down to here, and we have an add method invocation to add at a particular position in the list. We want to add the elephant at position 3. Well, in order to add the elephant at position 3, we need to shift everything else down so that elephant can come up here and get into position 3. Okay, so what we need to do is we need to shift the lemur from 5 to 6, the dog from 4 to 5, the cat from 3 to 4, and then the elephant slides in at position 3. And we know that's how it works because it was described to us in the interface that that's what's going to happen when you invoke this add method, the one that you send in a position and the new entry. So next up, we add koala into position 1. So again, we want koala to go in here at position 1. In order to do that, we have to shift everybody else down. So lemur moves from 6 to 7, dog moves from 5 to 6, cat moves from 4 to 5, elephant from 3 to 4, bear from 2 to 3, alligator from 1 to 2, and koala slides in here at position 1. Then we have just another add of just dog. Again, if it's the first version of the add method with no position, it just gets added to the end of the list. So this is what our list looks like now up to this point in the code. So then if we were to print out whether the list was empty, we would print out false because there are some things on the list. If we wanted to get the length of the list, there are 8 items in our list. 1, 2, 3, 4, 5, 6, 7, 8. So again, 8 items. The first index of our list is 1, and the last index is 8. So for our list interface, our list goes from 1 up to and including length. That is different from arrays. We all know that arrays go from 0 up to length minus 1, but this is not an array. This is a list interface object. And by definition of that interface, our list goes from position 1 to position length. Okay. Next up, we have a remove. We want to remove the item in position 1, so that's koala. So if we look back at our list interface, our remove returns the element that's on the list. So here we're going to remove koala, and that'll be returned to us. So this value is not garbage collected, but it actually gets returned from the method invocation. That's also different from a bag. Remember, with a bag, when we removed a specific entry, we just got back a true or false. With a list, the way it's defined, we get it back the actual element at that position. Now, once we remove that element, we then have to shift everybody down because our list is always going to start at position 1. So we shift alligator, bear, elephant, cat, dog, lemur, and the other dog. Okay, so now we want to get the entry at position 2, and that's going to be bear. Get entry does not remove it from the list. It just would return to us this object of bear. The next call does remove bear, so now we actually are removing it from the list, returning that value, and then shifting everything else down. Okay. Now if we were to get the length would be 6 because there are still 6 things remaining on our list. Next, we have a call to replace. We want to replace the item at position 1 with monkey. So here we've got monkey. We want monkey to go into position 1, and it's going to be a replace. What that means is we take alligator off the list and we return it. So this is going to be the return value of our replace invocation, and then monkey takes that place on the list. So now if we were to get entry position 1, it would be return monkey, wouldn't change the list, just give us access to that object. If we were to get the entry at position 2, it would be elephant. I don't have this listed on here, but what if I were to remove position 8? What would happen? Well, there's nothing at position 8. The list isn't that long. And so we saw from our interface that what would happen is that an index out of bounds exception would be thrown. Okay, so according to the interface, that's what would happen. If I tried to remove something from an index that doesn't exist, an exception will be thrown. Next up in my code is a clear. What clear does is it basically just takes everything off the list. And then next up I have get length. What would the length of my list be right now? It would be 0, right? There's nothing on my list, so it wouldn't throw an exception because my list still exists. There's just nothing on it, so the length would be 0. So that's an example of using a list interface object. Again, a key difference between a bag and a list is that a bag is unordered and a list is ordered. And a key characteristic of the list class that we are currently using is that our lists start at position 1 and go up through and including whatever the current length of the list is.